this video, we'll be going over how to write the names and formulas for ionic compounds that contain polyatomic ions. Let's start by defining that term, polyatomic ion. If we break it down, it means an ion that is made up of many atoms, right? Poly means many, atomic referring to atoms, and then ion referring to the fact that it has a charge. So what this means is it's a little molecule of multiple atoms bonded together, and that whole molecule has a charge. So since the molecule has a charge, we can just think of them as these bulky ions. We can even see in the diagrams of them here that they are molecules, but they have their brackets around them to indicate that they are this big bulky thing that have an overall charge. So these bulky ions have names that are always used. So they're like given names that don't ever change. We often see these in lists on our reference materials that look like this. There are lots and lots and lots of these, and I have more listed on my website if you're curious to find some more polyatomic ions. Another thing to note is the system for writing the charges on these can vary, right? So in this list, you can see that if it's minus, I generally will write that as a -1, right? So -1, a 2 minus here, I would write as -2 instead of 2 minus, and so on. Okay, and then another thing to note is ammonium here is the only positively charged one that we are going to see for our purposes. So that always has a charge of +1. Okay, so we're going to treat these like any other ion. They're just bulky. That's why we're talking about them separately. They are a little bit confusing because we do have multiple atoms in here. They have their own little subscripts, but we just need to be able to think about them like any other ion. So we're going to work through this with some examples. To start, writing the names. So when we see a compound that has more than 2 elements in it, right? Most of the things we've seen so far only have had 2 elements in the formula. Well, now that I have 3 elements, 3 capital letters indicating 3 different elements, that's our clue that we're dealing with a polyatomic ion. And that should indicate to us that we should use our reference tables and find our list of polyatomic ions. Okay, but then once we do that, all we have to do is follow the same system that we talked about for naming regular ionic compounds. We just name the cation from the periodic table or from the polyatomic ion list, and then name the anion. So if we look, okay, this is sodium, and then this is PO4. Okay, notice that sodium has its own little subscript, and then this is also why I had you guys memorize some of the polyatomic ions, was so that you could recognize them a little bit more easily. So I can recognize here that the metal or the cation is sodium, so I'm going to write the name of that. And then I'm going to look and find the name of the polyatomic ion. So PO4, if I search in my list here, here it is, PO4. Okay, yes, it has a charge of -3, but that charge of -3 is already taken care of in the formula. We don't worry about the charge. In this case, we're just matching that little formula with the name. So sodium phosphate. Okay, and that's it. That's the name of that guy. All right, so we can try another example. I'll do it in a different color. So Ba and then CO3. Okay, CO3 is that polyatomic ion here. Okay, metals are never going to be part of our polyatomic ions, so that's another clue for you. It will never be a metal. So if this has a metal in it, then we're going to write that as the name of the cation. So Ba is the element barium, and then we're going to find CO3 in our list over here. So CO3, oh, right under phosphate. Yes, it has a -2 charge, but that's taken care of when we write the formula. We don't need to worry about the charge, just the name here. The name of this guy is carbonate. Okay, you might be able to find some patterns, right? This is phosphate up here, phosphorus with oxygen. This is carbonate, carbon with oxygen. There are some patterns in the system that these were named in. So you might be able to identify those as you work through. All right, our last example for writing names here. This one's a little different, right? I have nitrogen, hydrogen, and chlorine. So these are all nonmetals, which is weird, but it's the clue that I have 3 different elements. That's my clue that I'm dealing with a polyatomic ion. So this is an exception to that rule of all nonmetals means covalent. In this case, this is an ionic compound because NH4 is an ion. So NH4, if I find that here, is ammonium. So I'm going to name that. And then I'm going to name the anion, which in this case is going to be chlorine. But because it's in a compound, we have to call it chloride. Remember, when you have nonmetals that are in a compound by themselves like this, you have to have the ending be "ide" to show that it is a compound. So this is probably one of the more tricky ones because they're all nonmetals. However, identifying that it's got 3 elements in there means we're dealing with polyatomic ions. Got to find that on our list, write the name, and then name the other part as well. So now we're going to go the other way. We're going to have the name, and we're going to have to write the formula. So let's start with this example, magnesium hydroxide. So we're going to follow the same rules that we have been. So I'm going to find magnesium on the periodic table. It lives in group 2. So it has a +2 charge. It's getting a little messy. Try that again. Oh, there we go. Okay, and then hydroxide. Hydroxide is a polyatomic ion. It is here. Okay, it is hydrogen and oxygen bonded together, and that whole thing has a -1 charge. If we think about how many of each piece we need to make sure that that charge is neutral, I need the charges to match that least common multiple. So I'm going to need 2 hydroxide ions to even out my 1 magnesium ion. Right? Mg is a +2. Each hydroxide is -1. So this is where it gets a little bit different. When I write this formula, in order to show that I have 2 hydroxides, I actually have to put the hydroxides in parentheses. Okay, hydroxide has to go in parentheses. We're getting real messy here. Okay, I can't write MgOH2 because that's referring to just 2 hydrogens. And in fact, it's 2 whole hydroxide ions. Okay, so this is my final answer. If you need more than one of your polyatomic ion piece, you have to put that whole polyatomic ion formula in parentheses. Okay, but notice again, in this final formula, there's no pluses written, there's no minuses written. It's written in a way to make sure all the pluses and minuses cancel out. Let's do the next example. Potassium sulfate. We find potassium on the periodic table. It lives in group 1. It has a +1 charge. Sulfate. Okay, this is not sulfide. It's this 8 ending. This 8 ending is also a good clue that you're dealing with a polyatomic ion. So we need to find sulfate. Here it is on the list. According to that list, the formula for sulfate is sulfur bonded to 4 oxygens, and that whole thing has a -2 charge. So we again need to figure out how many of each piece we need to even each other out. Well, the least common multiple is 2 again. I'm going to need 2 +1s to match my overall -2. So that formula then is going to be K2, and then I only need 1 SO4. So if I put that in parentheses, right, I could do that and say, okay, 2 potassiums, 1 sulfate. But I don't need the parentheses, in fact. I just can write K2 SO4 and have that be the final answer here. Okay, potassium, 2 potassium ions for every 1 sulfate ion. Next example, aluminum chlorate. Same idea, find aluminum. It lives in group 3, it has that +3 charge. Chlorate is down here, Cl Okay, if you're not sure if that's Cl or Ci, it's chlorate, so it's probably chlorine. Okay, chlorate with a -1 charge. All right, well, +3 and -1, the least common multiple of that is 3. So I need a total charge of 3 from both pieces. So that means 1 aluminum is going to give me that charge of +3. And then I'm going to need 3 whole chlorate ions. So this formula then is going to be Al and then in parentheses ClO3, and I need 3 of those. Notice this little formula did not change. It stays the same. It is chlorate. I just need 3 of them to even out my aluminum ion. Ammonium oxide. Ammonium. Okay, not an element. You need to get it in your brain that ammonium is a polyatomic ion. I have had so many students just be hunting the periodic table for the element ammonium. It is not. It is a polyatomic ion. So we're going to find it NH4 with a +1. Oxide is referring to oxygen. Oxygen has a -2. Well, in this case, I'm going to need 2 ammonium ions. I need 2 whole NH4 pieces to even out the oxygen. NH4, 2, O. Put this in a box also. Okay, 2 of these guys to even out that one. However, since this is this big bulky formula, you can't change the formula at all. We need it to look exactly the same. And so we just need to indicate how many of each of it we have, and we have 2 ammonium ions to even out our 1 oxygen ion. Our last example, lithium nitrate. Lithium lives in group 1, +1. Nitrate is right here, NO3 with a -1. This one's nice and simple. Lithium and nitrate even each other out in a 1-to-1 ratio. 1 lithium will even out 1 nitrate, and so that's our final formula there. All right, so that is it for polyatomic ions. Following the same rule, they're just big and bulky, so keep them all together. Keep them in parentheses if you need. If you need to kind of have invisible brackets on them so that you know not to change these little formulas, feel free to do that. But just know that you need to be able to recognize the formulas without brackets as well. Thanks for watching.